Hello, Assalamu alaikum, dear students. This is Electrical Machines Lab. Today we are going to perform lab number 1. We will look at how we can determine the polarity and turns ratio of a transformer in Matlab Simulink. Uh, First of all, let us look at some basics of transformer, how a transformer is constructed. As you already know, there are basically two windings, the primary side and the secondary side. Now, the winding is basically a coil. It's a piece of coil that is wound on a transformer core, and that core is basically made of iron. Now, this winding can be, can be wounded clockwise or anti-clockwise. So that's basically determines the polarity of the transformer. Okay. Uh, Conventionally, we basically have a convention on the high voltage side. We label them, like H1 and H2, and on the secondary side, we label it as X1 and X2. Now, depending upon on the polarity of the transformer, it can be either subtractive or additive. Now, what is this subtractive and additive? Let us look at how. Now, as you know, a transformer has two windings, right? Let's say this one is H1 and this is H2. Okay, and this is the secondary side. Now we have to perform the polarity test to determine whether this is X1 or this is X2 or this is X2 or this is X1. Now we have to perform the polarity test. Now, how do we perform the polarity test? We basically short out the primary and secondary side. We short it out like this, and then we connect a voltmeter like this on the other side. Okay, we also measure the voltage on the input side or the primary side, and we also measure the voltage on secondary side. So we have total 3 voltmeters, 1, 2 and 3. Okay, so now the first question is, why are we shorting the primary and secondary side? Why are we doing this, this thing and this thing? We are basically trying to do is, we can redraw this circuit as H1. Circuit starts from H1. We have this winding, then we have this point and this point. So this is the basically short connection, and then we have the secondary side. This is H1. Let's say this is H2. This is H1, and let's say this is, for the time being, this is X1 and this is X2. Oh, sorry, please excuse my drawing. So this is X1 and this is X2. Now, as you can see, if the polarity is this way, you know, the one voltage coming from this side and one voltage coming from this side, then the polarity will be subtractive. You know, this voltage will be subtracted from this voltage. But if the polarity is additive, then we have, you know, this direction, then both the voltages will add up, because we are checking the voltmeter, from the voltmeter, that this voltage connected between H2 and X2, is it subtractive or is it additive? So if the voltage appearing here is the sum of this voltage and this voltage, then the polarity is additive. If the voltage here is the subtraction of this voltage and this voltage, then the polarity is subtractive. So this is what we are going to do in the polarity test. And in the turn ratio test, we are basically we will measure the primary side voltage and the secondary side voltage, and we know that the turn ratio is basically the secondary side divided by primary side. It is the ratio of secondary and primary sides. That's it. So that will give us the voltages of primary and secondary side, will give us the turns ratio. That is usually denoted by A. Okay, so let's start with the MATLAB. You know, this is the circuit diagram that we have to make on Matlab Simulink. You know, as I have already described, uh, we have shorted out the high voltage side and low voltage side. On one side we have shorted them out, and on the other side we have connected a voltmeter, and we will be measuring voltage at this side, primary high voltage side, and also at this side. This voltage will tell us uh, whether the polarity is subtractive or additive. So let's make this circuit on Simulink. Okay, let's go to library browser. Oh, yes, we need AC voltage. Yes, we do need that, and we need voltage measurements. We need scope, and we need transformer, of course. Select the black one. Yeah, this one or this one, both are fine. Okay. Okay, the first thing you have to do is to go to the properties of transformer, and you can change the unit from per unit to SI unit. Simple. Okay, this is basically the rating of the transformer, and this is the frequency. You can change it to like 50 hertz. We use 50 hertz in Pakistan, so we can change that. Other than that, we don't need to change anything else. It's just the resistance and inductance. Okay, you need to uncheck this 3 winding transformer option. We just want 2 winding transformer, not 3. See, we just have a simple 2 winding transformer. Okay, So here is our transformer. Let's connect the AC voltage. Okay, uh, we do need to find voltage at primary side. That is our basically V1. If you see, we need 3 voltmeters, one at this, second at this, and third one is this. No, V1, V2 and V3. So let's make some copies. C1 copy, Control C and Control V. Okay, let's place it here. This will measure the voltage of primary side or high voltage side or primary side, and this. Okay, so we have to short out the primary and secondary side. So this is it. We shorted out the primary and secondary just like this. Okay, now connect the okay, now finally we need to connect the voltage between primary and secondary side. This voltage will basically tell us whether the polarity is subtractive or additive. So that's it. Let's name them so that we can, it would be easier to refer to that voltage. This is basically V1. This is V1. This is V2, and this is our V3. Okay, we need 3 scopes. Copy paste. A little hang. Create a bit. That's it. So our circuit is complete. Let's set the voltage. How much voltage do we have to set? Provide V is equal to 120 volts on the primary side, so we have to provide 120 volts. Okay, be careful about one thing. This is peak voltage, right? But in practical life, in practical transformers, we have RMS voltage. the voltage that you are getting from K electric is in RMS. That is not V peak. So the 230 volts that you are getting from the K electric is basically RMS voltage, not peak voltage. So if you want to convert between peak amplitude and RMS voltage, you have to use the square root 2 factor. I'm not doing that, but just letting you know. We have 50 hertz frequency in Pakistan, so let's have that. We have to multiply that 120 with square root of 2 to get the RMS voltage, right? Okay, so everything in place. Yeah, that's okay. Let's run the program. Oh yes, we again forgot the power GUI block. Whenever you use sim power component, any component that belongs to the sim power toolbox, you have to use the power GUI block. It is basically a solver, so you need that in order to compile the program. Okay, that's it. Okay, so we have to check v1, v2, v3. Okay, let's first check v1. Oh, sorry, this is v1. Let's zoom in a little bit. Okay, so this is basically, yeah, 100 around something. Okay, let's say 118, 119. Okay, close to 119. Okay, so this is peak voltage, not RMS again. So 119 is V1. Okay, what about V2? So V2 is around 51. Okay, around 51. Yeah, 51. Okay, so V2 is around 51. Okay, now let's check our V3. V3 is around 68. Okay, around 68. Okay, so V3 is around 68. So is it additive or subtractive? As you can see, the V3 is basically V1 minus V2, right? It cannot be V1 plus V2 because V1 plus V2 is 120 and 50 is around 170, right? So this is not 170, this is around 70, so it is V1 minus V3. So if V1 minus V2 is V3, then it means the polarity is subtractive. So secondary term is x1 and x2. Okay, so the polarity is, so the polarity of our transformer is something like this. is H1, this is H2, this is X1, and this is X2. In the subtractive polarity, the polarities are always opposite to each other, so that there is a subtraction of voltages. So this is how subtractive polarity looks like. On the other hand, the additive polarity is something like this. This way and this way, the polarities are in the same direction, so that there is a addition of voltages. So in that case, this would be X2 and this would be X1, the opposite case of subtractive polarity. So that's it. So polarity is subtractive in this case. But in the practical transformer that we had in our lab was actually additive polarity. The V3 was basically the addition of V1 and V2 in the lab. But here at simulation, we have subtractive polarity. So do this again for different voltages. Let's say 150 and then 200. Do this for different voltages. It would be same. There won't be any much difference. So V3 is basically a difference of V1 and V2. So this is subtractive polarity. Now we have to perform the turn ratio test. Turn ratio test is basically the V1 divided by V2, the voltage of primary side divided by the voltage of secondary side. So we need to make a simple circuit and measure the primary and secondary side of voltage. Okay, let's remove this short. Okay, and let's remove this voltage source. We don't need that for the transformer test. Yeah, that's it. So we just need this primary side voltage and secondary side voltage. Okay, let's run this program. Okay, so voltage at primary side is around 120. That's around 120. Okay, and voltage and secondary side is around 51. Okay, 51, 52. Okay, so voltage V1 is around 120, voltage V2 is around 52. So turn ratio is basically 120 divided by 52. So how much is that? Let me calculate. 120 divided by 52 is about 2.3. So that is the turn ratio of our transformer. And since the voltage is decreasing at the secondary side, so we can say that this is a step down transformer. Okay, so that's it. This was a simple polarity test and transformer ratio test. Now the $1,000,000 question is that why do we do this polarity test and turn ratio test? Why we have to do this? Why do we need to perform this test? The answer is In order for the parallel operation of transformer, we must know the polarity of the transformer and the turn ratio. So whenever we want to make the parallel connection of transformers, uh, we need to know the polarity and turn ratio. We need to fulfill these two conditions. There are other conditions too, but out of them, two are these conditions. One is the polarity and the second one is the turn ratio. So we must know them for the parallel operation of transformers. Now you might ask, why do we have to make parallel combinations of transformers? Why? Well, there are many reasons why we connect transformers in parallel. For example, uh, when the load uh, exceeds, sometimes load exceeds the normal rating load of the transformer. In that case, we need to uh, connect another transformer in parallel to that transformer. So that's why. And another reason is for reliability. If we increase more than one transformer in parallel, then if one is shut down for any reason, the other will take the load. So reliability of is one factor, is one reason why we do parallel operation of the transformer. Another reason is that uh, non-availability. For example, sometimes a transformer of larger rating is not available, and in that case we need to connect two smaller transformers in parallel so that we can meet the required loading. So these are the reasons because of which we have to connect the transformers in parallel. So this is why we need to conduct the polarity test and turns ratio test, because um, if we don't know the polarity, we would make the wrong connections while connecting the transformers in parallel. So this is why it is important to know the polarity. So this is how we do we do just like we did in a simulation on Matlab Simulink. uh, the same procedure we do this in practical to get the polarity and turns ratio test. So there's nothing changed. uh, you know uh, the similar process can be done practically on a real transformer, and we would get the same results, same kind of results. Okay, so that's it from lab number one. We would meet again for the lab number two, that is basically open circuit test of the transformer. There are several other tests that we perform on the transformer. So why do we perform short circuit test and open circuit test? Well, we will discuss in the next video. Okay, take care of yourself. Allah Hafiz.